Guten Tag, Australia. As you might guess already, I'm originally from Germany, from Munich. Yes, let's talk about moisture managed construction assemblies in Australia and New Zealand. Of course, I'm based in Sydney. That's why I chose this beautiful picture. But we want to talk about building physics and flat roofs. But before we talk about the flat roofs, we actually want to understand the circle of priorities, I call them. And when we have a building, we have certain impacts and requirements and priorities. We have water, we have vapor, we have thermal, and we have air. And now I want you guys to ask yourself, what do you think is the most important, and then the second most important impacts on structures, or on the structure. And I'll give you another 5 seconds to think about it, and then you'll see if you're right or not. Because normally it's a person-to-person presentation. And the answer is, in my opinion, is actually water. First, then air, then vapor, and then thermal. And the reason is why. If you ask me, what's with water? And if you just look over the ditch to New Zealand, and there's a nice book called The Rottonomics, and New Zealand still has to deal with massive problems of water leakage and problems. So we know, like from New Zealand, and also we know in Australia, every time when we have a heavy rain, we have significant and massive water problems in our structures. So that's why we have to deal with water first, because expensive parquetry and nice kitchen, it's all worth nothing as long as our building is still leaking. So that's why it's not acceptable. So first of all, we have to get control of rain and water. Then we can talk about air. But why do we talk about air first? Because I think energy efficiency is important. The building code is pushing for energy efficiency, and everyone is just, it's a big thing, isn't it? But we have to question actually what's generating energy efficiency, or why do we want energy efficiency? We want to save energy, and we want to feel comfortable. But now we have to understand what makes us feel comfortable or uncomfortable. I'm sitting here, behind me is a very drafty window. My hands are actually cold. I guess I'm used to it because I'm a chippy, but it's still uncomfortable. So what actually makes us feel uncomfortable, cold, is actually a draft on our skin, because like the wind is actually not removing, but it cools down the surface temperature of our skin. So that makes us feel uncomfortable. Nice. So actually, the air draft makes us uncomfortable. And the best way how to actually protect it is to understand what's happening. And air movement is always energy loss. And now let's compare it if we are a nice jumper, like hand-woven jumper like this one, on the weather like we have today in Sydney. Air will just get through the jumper and you're still going to feel cold. And so that's why the only thing with insulation actually is actually trapped air. And the insulation manufacturers, they learned it relatively early stages, because actually what they do, they sell you 98% trapped air and 1 to 2% fibers. So it's actually smart just to sell you air and make money with it. But they understand, like, you will have to trap air to actually have a good insulator. So that's why we have to stop air movement in our structure. If you stop now air movement, which we can actually measure with a blower door test, the tighter you build, the better it is. Stop air movements, then you stop removing heat to a certain amount. So 70% rough, plus minus, because there are studies around here in Australia. So 70% of energy efficiency is actually air tightness, not insulation. So now we build airtight, but now we have a very important next topic, and this is about vapor. And because as we build airtight, we feel warm now. Now we actually still produce moisture. We cook, we have a shower, we sweat. We produce moisture all the time, and it's free floating in the air. So what's happening with all the moisture? As we know, as a family, you produce around 200 liters a week of free floating moisture in the air. What's happening with all the stuff? As we know, airtight, it means kind of it can't get away. So normally vapor always goes the way of the least resistance. The first way was like convection, and now it doesn't work anymore. So now it starts actually to try to travel through the structures, which is called diffusion. So it means now it starts to diffuse through the walls in this case. And as plasterboard is highly vapor permeable, you can't consider that we have a lot of resistance in our structure. So it means we have to protect our structure from moisture traveling in a structure with a smart vapor control layer, which we're going to talk about later. So now we trap the moisture inside, part two would be we need actually a ventilation concept. And the thing is, like, if you trap moisture, like here in Tassie, it's a pretty good picture because, like, when we use this good old aluminium foils are a perfect vapor barrier. Sitting in this case on the outside of the structure is a nightmare. And this can happen after a few years of a structure. So that's why you can't have vapor barriers on the outside of the structure, which we're going to talk about it too. Handling and understanding moisture means kind of you have to understand different types of leaks. We have an energy leak, which in my opinion is most times when you have a thermal bridge. So if you have a steel structure or steel beams, which are attached to the outside and the inside, you could create cold surface on the inside. And this is when you create something called a thermal bridge, pretty well known from the passive house movement. And you could have mold spots on your plasterboard on the inside. A more tricky one is a moisture leak, which would be actually via convection again. So it means kind of you have a leak on one end, slowly the warm, moist air is traveling to the outside. It will condensate on the way to the outside. And this would be a typical moisture leak because you have on some random spots, you have actually mold and condensation and rotten timbers. So that's why I would always recommend understand these two types. So now I would say like we have a rough understanding of moisture too and thermal. So what's happening with thermal now? And the answer is quite easy. If you actually control water, air, and vapor, thermal comes as a bonus. So now you can put in as much insulation as possible and you can't stuff up the system anymore. The reasons why I'm really so clear on it is because in the world, in the most parts of the world, specifically in Germany, 1980s, 90s, we've pushed on thermal. And there's a study, Australia-based study on moisture management and condensation, which we're going to show you later on. They're actually focusing just on that one. So that means kind of we all had these problems because the more insulation you put in the structure, the higher the temperature difference between the inside and the outside is, the higher the moisture drive is, and the higher potential damage of your structure is. So that's why we have to get water, air, and vapor right first, and then we can have thermal as a side effect, as a positive side effect. Still, there's a long journey to go. Specifically, like I live here now for nearly 6 years in Australia, and my place where I live feels a little bit like the shed on the left side. And we consider the roof is intact, but do you think they have mold problems? And do you think they have condensation problems? Now, the quick answer might be no, because this building is so drafty and leaky that there's no temperature difference between inside and outside. There's no moisture difference between inside and outside. But we all agree that this on the left is not the place we want to live. We want to live something like here on the right, which is a passive house, which at the moment is the highest building standard internationally we have so far. So let's get on the way. And first of all, we have to leave the past behind. And this is the good old aluminium foil. We still see heaps on building sites, which, by the way, most of the Clima zones in Melbourne and Sydney is actually illegal because aluminium foil is a perfect vapor blocker. And what it does is you actually have internal moisture traveling through your structure to the outside. It's going to hit the cold surface in the aluminium foil. You have condensation. Why? There's a good example, like if you wrap your fish on the barbie in aluminium foil, it keeps the moisture in, isn't it? So that's what you want. That's the purpose of an aluminium foil. If you do the same to your house, you actually wrap the moisture off your house. You keep it in. So you don't have any drying potential. So that's why the building code says in climate zone 4 to 8 now, you have to use a class 4 vapor permeable membrane on the outside. Perfect. What you see here, class 4, cladding on top. That's, by the way, code compliance at the moment. And you already can hear my sarcasm. You still have condensation because it doesn't help you if you have something not vapor permeable on top of something vapor permeable. You still trap moisture. Still the same issue. The quick answer here is you just separate the two layers. So now you actually have internal moisture traveling through, which is a typical cold climate condition. It's traveling from the inside to the outside. As you separate these two layers, now your structure is actually allowed to dry. Now the moisture can escape and you can ventilate it out. And if you have condensation, because you might hit a metal cladding and you have condensation, now it can drain down. So we call this a drained and ventilated facade system. There's still a risk because, like, if you introduce too much moisture in a structure in certain climates, you still might have the problem that your structure can't dry out fast enough. So you still need a smart vapor control layer on the inside to stop moisture getting in your structure. But you still, if you have moisture in your structure, you have the maximum drying potential to the outside. And as you see here on the left, that's what you call the perfect wall, because you have a smart vapor control layer on the inside. It's fully insulated, a weather resistive barrier on the outside. And this is actually a damage-free structure. And as you can see, the perfect wall is actually like the perfect roof, or the perfect roof is like the perfect wall in this case. So you see here on the right, which is in this case a skillion roof, you have a fully insulated rafter tail, the membrane directly attached to the membrane directly attached to the insulation to allow direct moisture transport through the structure. And now, as you have a proper ventilation drainage gap, you actually ventilate the moisture out in winter. And another positive side effect, because as you created a ventilation layer on your roof, because you don't use these anti-com blankets, you actually create a chimney effect also. So you actually, as you create an airflow in your roof structure, you remove heat in summer, which has a pretty good effect in both directions. So finally, going to the flat roof is kind of why do we build flat roofs? And we all agree that's actually a pretty nice view here. It's in Clovelly in Sydney. And the worst case, what can happen is that you have a building site. So at the moment, there is actually a massive building site in front of this house. And the worst case can happen is the whole nice few $1 million view is completely blocked now. And we all agree that's not what you want. So now the big gambling and negotiation will start. We try to fight for each single degree on your roof because you want to get it down. And now it makes sense why we actually want to go down to 2 degrees, because at least you have something left from the ocean view, isn't it? So there's a reason, because we have height restrictions, specifically when we live in dense areas. We're not talking about outside of big cities, and we want to have the views. So what's the difference here? If you go back to the building physics perspective, that's best practice in a traditional way. You just put the anti-con over and hope the best with a ventilation layer below. We specifically in Clima, we're pretty precise with our recommendations. So we say, like, if you're above 10 degrees, you can use the membranes, flexible membranes right over the rafters, unsupported. We say if you're 5 to 10 degrees, then you should always use a board, because the biggest issue here is kind of membranes always sag a little bit. So you can't have ponding water on your roof. You all agree having a pool on the roof is not a great idea. We always want to avoid it at all costs. So that's why put a board on, put the membrane on top to stop sagging of the membrane. And using some certain accessory products like the nail penetration tape, and maybe using a membrane which has an integrated tape, which performs significantly better than other membranes, is definitely a big recommendation here. If you're above 15 degrees, same again. I don't even know why I have this slide in, because it's a double up. Sorry for that. The thing is, like, we want to understand where we're actually coming from. And as I said, like, having the anti-con system or like roof blankets on 2 degrees pitch, which is still code compliant, which is a big issue, because like you have a water pool, and as you see here, you don't have a drainage layer. And as you can see here on the right picture from Tasmania, you can trap a lot of moisture even if you ventilate it, because you still create a cold surface on the inside of your roof structure. So there's a good reason why Tassie mainly, or you barely see any aluminium foils in Tasmania, even if it's still legal. So then let's just retrofit or deconstruct the structure. So we just remove layer by layer. And the first thing we're going to do now is we actually fill up the rafters completely with insulation, because you don't want the insulation layer, because we have something like wind washing, which we're going to talk about in a second again. You directly attach the membrane, you tape the overlaps, because you don't want any wind getting in your insulation, reducing the performance of your insulation. You put counterbattens on, in the best case with a nylon tape, which is kind of a nail penetration tape for low roof pitch, purlins and roof cladding on, and easy going. So as I said, you remove moisture in winter and heat in summer. So now you can tick all the boxes for summer and winter condition, because you have the perfect roof cassette. As you have no drainage layer properly on the left side, you will trap the moisture, which definitely reduces the performance of your structure over a long period of time. But what are the challenges? The thing is, the reasons having flat roofs and the issues with the flat roofs is actually like ponding. And the thing is, like, whenever you install on low pitch roofs, when you install the membranes, you can install it as perfect as you want. And I consider myself a pretty half decent chippy, and I work with these membranes for quite a while. So my installations are pretty neat. And even if you have a perfect install like here, membranes will always sag a little bit because they start to relax under heat, which is quite normal, which is a good thing. Because if membranes would actually tighten up under heat, then you actually would create a lot of stress on the tapes and on the fixings. So this is what you want. And even if you look at this building site, it's a perfect install. You see, like, it's nice and taut, it's shiny. Oh, it's just beautiful, but it's 1.5-degree roof pitch. So it looks great, and you might be confident it won't leak. And then just the day after, that's exactly the same roof under 1.5-degree roof pitch. So even the best products on the market won't help you. You still have water pools on the roof. You have like water wicking through the fleece via capillary. And we all agree that's not a good outcome. And this can actually happen just based on condensation underneath your roof too. So that's why we all agree it's not how it works, or it's not like what we would sign off. By the way, if anyone has questions, just type it in, and you just interrupt me and ask me the question. That's totally fine. I would like to have it as interactive as possible. To find out where the problems are and how to solve them, because the problem is when you have a low pitch roof, it takes quite a while for the water to run off. At 2 degrees, sometimes water is just sitting there, and if you have a little bit of wind pressure, water can't run off at all. So it means you have water sitting on your joints and on difficult junctions, wind pressure, because you have wind today, and the wind pressure will just drive the moisture through all gaps and cracks, even via capillary. So that's for me. Before I said, okay, let's figure out where the problems are, I really wanted to understand the problems. To be code compliant for membranes, you have to hold 100 millimeters of water for 24 hours, which equals 1 kilopascal. And to be honest, like when I was building this box, it was back then during COVID, I was pretty confident. So I thought like, easy. I know exactly what's happening and I know it all. I'm smart, and I just started it. And I came up with all sorts of funky ideas and basic ones, and oh, it was leaking. So there was a first kickback. So actually, I wasn't as smart as I thought. So I had to change my detail, and I used a specific stretchy tape to actually seal it around. Then about the chimney, I already came up with a super fancy origami taping technique how to tape around chimneys, because I wanted to avoid other products. And I thought, oh, it must work for sure. And 3 or 4 corners leak too. So another big learning for me. So I had to change it again. I went back to a stretchy tape because I just realized having the right products for the right applications on the end is fast and cheaper. And this is how it went all the way through. And this is how I came up with the Flat Hero system. We're pretty precise how things are working. And as always, we have to think it as a system. So never, and it doesn't matter if you talk about our Proclaimer products or if you talk about other competitor products. We always think about systems, not products. It's very important. And also it's important to understand how a structure is working. So it means the roof structure, we always trying to create the highest drying potential of this roof structure. So that's why you always recommend having a smart vapor controller on the inside to stop internal moisture getting in our structure. And we want to have the highest drying potential to the outside too. And we also have to understand that building materials are never 100% dry. My experience here in Australia is quite often the opposite. So sometimes it feels like we're trying to introduce as much moisture in the structure before we cover it up with membranes. So the important part is like we have to keep our structure dry over the whole period of time. When you have a standing seam, it's kind of tricky one. So the standing seam, specifically in this buildup, you really always have to have a separation layer. So you can't have standing seam directly on the membrane, because otherwise you have a cold surface hard against the membrane, and you're pretty surely you might end up with a soggy board. So that's why this separation mesh, even if it's just 8 millimeters, allows a drainage layer for the standing seam or flat metal roof. Very important to say, this is not a ventilation layer. This is just a pure drainage layer and separation layer. And this system has to work with a smart vapor control layer only, because there's nothing else which can actually make it work. Also, as this will be never ever a deemed to satisfy solution, you have to do woofy calcs, and the matter of the roof, the color of the roof will matter. And in quite a few climates and orientations, you actually have to go with a dark colored roof, because a white colored roof, I know that the market is driving to white colored roof because we don't want to have overheating of our roof structure. But if you have a white colored roof, you might have not enough energy to allow your moisture to drive back, because in summer, when sun hits the roof sheets, it actually creates a reverse moisture drive. Now your structure can dry out to the inside, because we have this magic smart vapor control layer in here. Same with materials, also can dry out to the inside. Very important is, the better case is always if you can separate your roof sheeting from the membrane, as you can see here, and you create a proper drained and ventilated roof structure. The thing is, as we have a very, very low roof pitch, we have something like a stagnant effect. So we don't have a proper ventilation layer anymore. And that's why the ventilation heights will get more and more and more. So we say, like, if the roof is up to 10 meters, you should have minimum 50 mil ventilation layer. If the roof is longer than 10 meters, you should actually have 150 millimeters ventilation. I know no one will do it, but it's very important to mention, because the international studies from Germany, from the Lund University, from the US, that ventilation is very important to actually get rid of moisture. And these are based on the German standards. I know it will take a while before we implement them, but I think it's very important to understand the risk of moisture in our roof cavity. We have quite a few technical articles regarding this topic, and it's called Above Sheeting Ventilation. Technical articles, you can all download them on the Clima website. It's nice to talk about all the theory and having nice thoughts. And when I got you right, I think we have quite a few architects here today, isn't it? So what's our biggest concern? You can even comment it, Carlin, if you want.
Because everyone takes on the roof would be workmanship and making sure there aren't leaks, damages, punctures that can happen unobserved.
Yes, exactly. So it's really important that the things we are planning and all the good ideas and the thoughts we're putting in to make this roof structure work, same as the wall, so the whole building, is actually the workmanship. So that's the how is very, very important. And this is what my specialty is, of course, as a GP with quite a few years experience. I really focus that we have proper installation guides and the understanding of the market, that people really know exactly how to install it. And that's why each single step actually matters. A little one, just you see like the nail is sticking out, you have to hammer the nail in, because if you have the nail sticking out, you just walk over it, you're gonna pierce the membrane, you have a leak again. So you just spend a bit more money to have a better system, it won't work anymore. Install it properly, nice and taut, don't have any wrinkles, because if you have wrinkles and overlap, you can channel water back again. Using the primer P here to stop capillary is something I came up with, because you really want to stop water slowly moving upwards against gravity, thanks to wind pressure. Corners and details and bits and pieces. So it's very important to use the primer again. You really nice fold it into the corners, prime the overlaps, and use the stretchy tape around the corners, because this actually really brings a pretty perfect outcome. And the idea is why I'm so precise, because if you just follow the steps, it's going to always work based on my experience. So it means kind of whoever is installing it, you follow these steps, and it's a pretty safe system to use. The same was in internal corners. I actually prefer not to tape internal corners. Okay, watch some Japanese origami videos, and then you see, okay, you can just fold it inside and it looks quite perfect, because I didn't cut on the internal corner, as you can see here. Because every time when you cut, you introduce another risk, and this is what we're trying to avoid here. Same pipe penetrations, you just prime around, use the stretchy tape, and you work yourself all the way around the pipe. And it's pretty easy. It looks more dedicated than it is. So it was actually a pretty easy detail. Also, like when you have cables, cables is a tricky one because like we in Australia, we have flat cables. Most of the world has round cables. Round cables, we have grommets and they seal really, really well. With flat cables, in this case, it's always difficult. I have some taping techniques, how you can tape it. But as you can see, there's little corrugations. It's nearly impossible to push the cable properly into the corrugations. So I use a conduit or like a pipe offcuts, use a grommet because we know the grommets to seal really, really well. Run the pipe through, the cable through, and on the end, when you finish, just seal it up. And then it's a perfect seal. Also, in my opinion, we shouldn't run cables while we run membranes and while we try to seal the structure. So that's actually also much, much easier because you just do it afterwards. Would you agree? I would say yes. Specifically with data cables, because if you break like a 50-meter data cable because they just want to run in the beginning, it's a pretty expensive exercise. And we talked about the roof patterns before. So whatever it's below 10 degrees, you can have water wicking through the screw penetration. And we know that this is happening because I've seen in Australia, that's code requirement in Germany for around 15 years. For all roof pitches, we in Australia just say below 10 degrees. And that's why you have to use something like a butyl tape. It's a nail penetration sealant tape. So what you do is you just put it underneath and the screw, because there's so much glue and it's so sticky that when you drill through the glue, the screw is pulling the glue into the hole and seals it from the inside. And it works really, really well. And it's well established on the commercial market already. Last but not least, most likely the only way how you can make this system work is with a smart vapor control layer on the inside, like our Intello here. Did someone say Intello? So as we said, the smart vapor control layer, and of course now I'll talk specific about our product, is relatively new on the Australian market. We of course not the only one who's selling these kind of products, even knowing the differences in the products, but it's not part of the topic today. So why are we using the Intello in a smart vapor control layer? I always would say like treat your wall like a fancy exclusive club like the Berghain Club here in Berlin. And I'm pretty sure everyone heard about the Berghain. And everyone wants to go there because it's the world's most famous club. And but we all know that this club has the hardest bouncer in the world, isn't it? And we all know it's actually quite difficult to get in. And that's exactly what our smart vapor controller is doing in Intello. So Intello stops moisture to get in your structure and it saves all nasty people or the nasty moisture out. So what it does is because it's pretty vapor tight on normal conditions, so it barely lets any moisture in your structure. So back then, we could just use a polyethylene sheet, isn't it? Like just a plastic foil, and you just block the moisture getting in your structure, isn't it? And this is what we did in the past. Where is it? Oh, there it is. So back then, we just used a smart as a PE sheet to stop moisture getting in. The problem is, if you remember the aluminium foil picture before, exactly the same is happening now on the inside. Because what's happening in summer is like we have high humidity on the outside, and specifically when we talk about Sydney, where we have 80% humidity over a very long period of time, even months. You have a lot of back diffusions. You have external moisture trying to get to the inside of your structure, to the inside of the structure. So if you have a PE sheet now on the inside, you just block the moisture and you actually have molds and rotten timber on the inside on the structure. We had even these problems back in Germany. So that's why we need a certain drying potential. So what it is it's not a vapor blocker. It is what you heard me saying quite a few times today. It's a smart vapor control layer. So it means kind of it's vapor tight in winter conditions when internal moisture is trying to get in your structure, but in summer when you have back diffusion, it actually allows moisture which is trapped in your cavity now to escape to the inside. And that's a pretty
How does
slow.
that work?
Yeah.
How's that possible?
So the long story short is we have a variable diffusion curve. So as the PE sheet, polyethylene sheet, sorry, is absolutely tight and constant, the Intello changes the properties based on the humidity level on the backside of the Intello because there's a fleece. The fleece will absorb the moisture, and then what you have kind of it's a moisture-loving material. So that means the fibers will getting longer and it releases the moisture to the inside. And what's quite unique with our products in this case, that you have 100 times difference in humidity variable diffusion resistance. So that means kind of it can get very, very vapor open, but on normal conditions it's pretty vapor tight. And the big differences between the manufacturers is how the curve looks like.
So that curve is derived by the makeup of the sheet and the differences between different sides on the lengths of the fibers at a very small scale.
Sorry again?
I'm trying to get my head around exactly
Yeah.
how, like, mechanically
Yes.
this can change with temperature to push and humidity to like, it just sounds, it's very interesting to me that there's any
Temperature,
material can do that.
also temperature is the driver for moisture, because like we create pressure differences between one side of the structure and the other side. So mainly like the basics of building physics is that high goes to low,
Mhm.
high temperature goes to low temperature, and high humidity goes to low humidity. So that means kind of temperature or the vapor pressure is the driver, and the moisture content is kind of because the fiber of our membrane reacts to the moisture content. And as the fiber lengthens, means kind of it opens up the structure, and this is why it allows more moisture to go through the structure.
That's fascinating. Thank you.
Yes. And
Can it be installed like the wrong way? Is it sided?
yes, it's sided on the inside, but it's mainly based because like one side is the functional film, and you can just tape on one side or not on the other side. But you can see it's clearly like there's a writing one direction and the other side is the backing fleece. And it's also important because the backing fleece, it makes it much easier for the moisture to sit on the fleece. And then when the moisture can sit on the fleece can absorb the moisture, and then the actual functional film will react properly to it. Before, the important part is it has to react before it forms a water molecule. So it's all diffusion what's happening in here. And now your big question is kind of Australia. We have so many different climates, and how do we actually understand how it is working? There's something like a performance criteria in the NCC. And I think it's one of the biggest changes we had in a very, very long time in the year 2022, that we have something like a mold index can't be greater of 3 following the RDO7 guide. I don't have enough time to go into detail what it means, but if you have 5% mold coverage on your structure, you have a problem, visible. So the thing is, like when we have mold in our structure, it's already too late, isn't it? So the idea is when we plan a building, when we build a building, we actually try to avoid all these problems because we want to get it right from the beginning. That's why the building code has now a specific guideline which you can use for commercial or residential, because you have to deem to satisfy. And whenever you build not to deem to satisfy, you can follow the verification method here from the building code. And what it does is you use WUFI, that's a hydrothermal analysis program, and you really put in all your wall buildups, and then it actually calculates over 10-year period if you want so, and with the real climate data, with the real material data from the Fraunhofer Institute back in Germany, what the condensation risk of your structure is going to be. And that's quite interesting. So it means kind of we don't have to guess anymore how the structure and buildup is going to be. Now we can clearly calculate it. And as you remember, we went to the World Conference of Timber Engineering last week. And there was one presentation about a girl, she built a CLT building in Melbourne. And she actually did WUFI calculations, and they put sensors in the structure. And actually the sensors showed the exact the same or nearly exact the same outcome than the WUFI calculation. So you see more and more people that actually we know it's working, even on the other side of the world. And the Fraunhofer Institute was actually working like over 30 plus years to get this one right. And it's part of the building code, which is a good part. As I could talk for ages about building physics, we have heaps of technical articles specifically about above sheeting ventilation, which you can download for free on our website. But maybe you can say what you think about it. But one of my workmates, he wrote something like a masterpiece, the Australian-based study on air tightness and moisture management. You can also download it. And sorry, Kylan is already reading through it. And I think it definitely helps everyone to get a good understanding about the different climate zones, what the building physics is behind our structures, etc., etc. And this will be it for me. Even if it just doubled the size of my presentation, I still was a bit too fast. But I'm pretty sure we have heaps of questions, as I
Yes,
hope.
we do. Thank you so much for that
Nice.
presentation, Daniel. And yeah, thanks again. Um, with the change in topic, I was thinking to myself, who do I know that can talk very deeply on an important topic on short notice? And the
Very
one
short, yeah.
and Daniel was top of that list. So thank you for being here, Daniel. And it was great to meet with you at the conference.
Yeah.
We have a few questions. Stephen Hughes asks, have you got a detail for tile roofs?
The details are more or less exactly the same because you install the membrane over the rafters, then you put the counter batten on. The spacing will change. The spacing between the trusses will change because you have requirements by the building code. Most times you have to use a heavy duty or extra heavy duty membrane, which we have too. But I recommend go down to 600 millimeters in spacing on the heavy duty membrane, and it should be all right.
Mark Dewsbury asks, Daniel, and I don't fully understand this question, but perhaps you do. Daniel, please describe the inverse differences of water vapor diffusion resistivity factor and the AS 4200 water vapor permeance values.
So now he got me exactly because with the permeance numbers, this exactly, I know Mark pretty well. Shame that Willie is not here because that would be his absolute topic. I have to read this question again. Where is it?
It's in the webinar chat.
So yeah, describe the difference of water vapor diffusion with a factor. I couldn't even tell you because I'm not a building code specialist, because that's Willie, because I'm more like the how-to person. So we can definitely really is happy to write something about it, and then we can definitely send it out to the guys.
Is this an evolution of our codes slowly? Is it a terminology? Is it a place where the terminology is occasionally confused? Is that a
Yeah,
problem?
because first of all, because I'm not 100% up to date with the ACE 4200 to each single word, because in this case, we talk about the exact wording and exact detailing. And this is exactly where I try to stay out of it, because like we have 3 people here in the office who are absolutely professionals in the building code. I really focus how to get it right on the building side. So that's why. Thanks, Mark. You knew exactly you
Good
knew
to have the
exactly that I
belly.
can't answer this question.
And it's just incredible, like the level of, I'll just try and share this slide a bit. Like is that clear? Probably not. No, it doesn't look. Anyway, the point is that there's a lot of very, very specific terminology to describe these phenomenon. Um, and it's certainly not simple, even though the basic principles are simple.
Yeah.
Um, it's fascinating.
Uh,
Um,
Mark just answered. It said it specifies the water permeance properties, many products, and the presentation showed water vapor resistance. The inverse properties, do not get them confused. Yes, that's like when we talk about the specific wording. So what Mark is saying here, that we have different wordings around the world. Like for example, in Germany, we see it's SD value, and I get it confused all the time too. But this is what he means about this precise wording of these systems. Yes.
Jerry Howard asks, or comments and asks, the challenge in Australia is to get builders to sheet across the trusses to provide membrane support. The other issue is roof buildup, which is a challenge with standard depth fascia and barge. On low-pitched roofs, would you recommend an anti-ponding device to train any condensation into the gutter?
No, because like if you're very low already and you just put a kind of a wedge on the bottom of your roof structure, then you actually create a negative roof pitch or like a 0-degree roof pitch again. So in this case, I always recommend just change the details a little bit. I had a kind of a big presentation where we actually had the roadshow to the study, and on the ProClimber YouTube channel, I have a long presentation, about 45 minutes, where I talk about this specific detail too, because like, it would be way too much to talk about it. But my approach is that you actually drain your roof behind your fascia board or your fascia, metal fascia, because when you see like when you have the fascia board the height of the gutter is related to the fascia board because it sits on the top edge. And that's a bit of a difficulty. So I don't think that the height and the installation method of the fascia board should actually dictate the physics and the performance of our buildings or of our roof structure. So that's why I prefer to separate it, have a mesh behind, then you create a proper drainage and ventilation layer because it's pretty difficult detail. So you have drainage
Yeah.
and ventilation behind your fascia, metal fascia or fascia board. And then because the fascia clips, you can also front fix them. You can side fix them or you just bend them to 90 degrees and you can front fix them. And this, in my opinion, is the best way how you separate it. Because if you have a high water builder, roof buildup, because you have a counterbed and you batten, you're getting higher. And if then the roof structure is too high to the gutter, then you might have, when you have heavy rain like today, water will just shoot over. So you always need the height right for the guttering to your roof. And you want the height right also for to get the drainage and the condensation out of your roof structure.
Mm. So that portion behind the fascia would drain at the bottom of the wall.
Now, also, of course, if you would have in this case, if you have a wall like the typical boxy style of houses, then most likely I see it way too often and people draining into the wall, which we generally not recommend. We recommend separate your wall and your roofs as a drain and ventilate your wall structure separately from the roof structure.
Right.
Yeah,
Right.
but I really talk about in depth because you need a lot of pictures and
Yeah.
nice droplets, which I really excessively talked about in this presentation. Sorry to push you to the YouTube channel, but really for you to have the best out of it, I would recommend you to go to have a
Further
look to it.
reading. I mean, yeah, that's part of it. Generating further reading.
Yeah.
Frank McMullen asks with regards to CLT walls, would and tallow sit on the outside of the walls as the insulation zone is external to the panel? So I believe
Yes.
Frank is saying we have CLT, the insulation, and then we have our Intello on the outside.
Most times I would recommend using the Solitex Adhero because you wouldn't need the Intello on the outside and it wouldn't be the right product to use to because the Intello is an internal product and you actually want to minimize the vapor resistance on the way from the inside to the outside. If you would have a CLT wall in the tropics, let's say north from Brizzy, based of course on a woofy calc, you actually would go with a higher resistance like the DA, which is a class 2 vapor barrier. This is what we would recommend in the tropics, but in general, the Intello normally is not the right product to sit on the outside, specifically in high humid areas like in Sydney. So in this case, you would go with a peel and stick membrane. Adjust your resistance because sometimes you want a bit more resistance like in Sydney. Yeah, just use the right product, but no Intello, just use CLT, peel and stick membrane or the adhero on the outside. And then wood fiber or external grade rock wool on the outside because you always want to be vapor permeable to the outside.
Yeah, and of course the CLT is more or less vapor, or do you just consider it vapor impermeable, a CLT wall?
No, because timber is actually pretty vapor permeable,
Mm.
but I couldn't tell you what the exact resistance is. But it's still like the good thing is with the timber wall, if you leave it as exposed to the inside as possible, you have a big buffer on the inside. So it actually works really well to absorb moisture and release it again, specifically if you talk about different phases over the day and over the year. So that's why having
Mm.
CLT as a material is a very nice material for the air quality on the inside and the moisture quality. That's why it works well.
Fantastic. Got a question, of course, the perennial question of cost.
Yes.
So the question is about how much would a full system, I mean, obviously, in a hypothetical building, add to the cost of a new build. Of course, that's a
We
difficult question to answer, but I'm sure you get it all the time. Yeah, what are your thoughts on that?
we talk about not a flat hero system or in
Um,
general like building better.
uh, let's say let's just keep it to flat roofs and say
Flat
how much
roofs.
would a
I
Daniel
still I
Decker
still
thumbs up
couldn't
flat roof?
I still couldn't tell you because I stay out of sales. Because I'm purely technical and I focus on the solutions. I can see have been used excessively Australia wide. Just a fun fact, I actually developed the system for the Australian National Library in Canberra because they had a 4-degree roof section and a 7-degree roof section. And they really said, like, mate, it's the Australian National Library, 6,000 square meters of roof. We can't have a single drop. That's what I thought, challenge accepted. And on the end, I can't tell you because like I'm not sales, but whenever you look up the prices and you can find out partners who give you the pricing immediately, um, compare the price with the value and the potential problems you might have in the future.
Definitely, definitely.
Yeah. I
Um,
think we jumped over Paul because Paul Davis had
yeah,
another
Paul,
one.
yes. Well, Paul Davies asked, you showed how to keep the vapor inside the building. What's the best way to get that vapor out? Now, um, I thought you addressed that in the
But let's
the
just
philosophy of
double it
the
up. That's good.
membrane is
Because
to get the water out, but please.
it's quite easy. You just need a ventilation concept. I keep saying, like back in Germany, we don't have ventilation systems, very, very rarely, and we just close our windows a few times a day, and this is how we get rid of moisture. But you lose energy. And the other thing is like our climate is forgiving because we don't have a high humid climate back in Germany, specifically South Germany. So the best and the one and only way how we really can get it right over the future is have a smart have an HRV, heat recovery ventilation system, which is a balanced ventilation system. Because like if you create over and under pressure, it could be always difficult for the building. And the heat recovery systems also actually keeping the energy in your house because you won't waste any energy in the structure. And it also just runs 24/7. And the efficiency of these central heat recovery systems, they are actually around 96%. So very efficient. And the running costs over the years maybe less than $50 a year. So it's like 8 coffees, 7 cups of coffees a year. So yeah, that's what it is. I'm not a big fan of like exhaust fan only because first of all, in a massive thermal bridge, and where is the fresh air coming from? If you have an old leaky house, then you can imagine it comes from your leaky floor on your skirting boards, and so just be all aware when you just drag it in.
Yes, the perennial challenge is to bring the long term into view because it's so easy to ignore the costs 20 years down the line, or even 10 years down the line.
It's also like a bit of a building code. So you see the building code is changing over time. And when we talk about like the Intellos or the smart vapor control layer, you still see like for most people it's kind of a bit crazy. But I'm pretty sure it will take less than 10 years and we will see it in the building code. Because if you
Mm,
do, and this is where I know that Mark Dewsbury is pretty proactive also because I know like he does a lot of research about moisture issues in Australian buildings in all climates. And we definitely will see a trend that it might be required in a few years. Specifically, if you put more insulation in, we're using better windows, because every time when you introduce a better performing part of your structure, you change the performance.
yes, yeah. It does seem inevitable that we will lead perhaps in the reverse of your original directions,
Yeah.
but we will inevitably arrive at a point where these things are mandated. Um, John asked if you could show the publications screen again.
I guess
Yeah,
this one.
yeah, yeah,
Yeah.
I think that's the one. Yeah, great. Um, Sergio asks, when looking at providing the ventilation layer on a roof, what would you use at the bottom and at the top of the roof, at the gutter and the ridge cap, to provide airflow but stop vermin etc getting in?
Yes. That's a good question because it's practical, first of all. So I always have something like a cavity closer, um, but I don't like the word of a cavity closer because very often you see the Bunnings plastic cavity closer, which have a little slit in it.
Yeah.
And that's definitely not enough. So when we talk about ventilation, we as Proclimer, we recommend at least 20,000 millimeters square per linear meter for ventilation. It seems like the new building codes is going to bring something up which is significant less. But our numbers are based like on international studies, as I said before. And important is to mention that you really have to focus, or you have to keep an eye on what mesh you're using. Because if you use a kind of a cavity closer, the smaller the mesh is or the perforated metal, the more you block the airflow.
Mm.
So that's why the opening rate, which is again, I talk about this on my presentation on the YouTube channel. The more you block it off, and the less airflow it is. So you should have something like a perforated mesh or mesh, which is custom made. I always recommend go with a custom made one because off-the-shelf products at the moment in Australia, they're not good enough for better buildings at the moment. It will take a while until the market will adapt to better buildings and steps away from the should be right might method.
That's a great tip because surely your local roofing company could fold up your
Yes,
perforated sheet.
yeah, just here across the road, there's a shop's called the Roofing Supermarket, and they just can bend whatever you need, and that's what's quite easy, fast, and it's not even overly expensive. On the ridge cap, there are different solutions. There's something like a venter roof, it's called. We have 2 details on our website, so where you could actually fold the mesh around. So it's difficult because these are details I normally would draw up now, but as we are on screen, it's a bit difficult to draw that one up. So have a look also on the website on the details. We have quite a few details on it.
Fantastic. Lots of homework, everybody. Paul Davies asked again, is the purpose of the battens inside the vapor layer solely for running services?
Yes, not purely, but yes. So the idea is when you invest the extra time and the effort and you spend extra money to actually installing your smart vapor controller on the inside, you want to protect it. And you will see, and specifically in older buildings, small buildings, you see quite a lot of direct fixed plasterboard on the inside. The thing is, like, if you fix the plasterboard directly and you hang a picture or you have other surfaces, now you have to treat all the penetrations. So there are 2 ways. First of all, because you have all the penetrations like plumbing, which you shouldn't have in the external wall anyway, and cables, you have to seal them all separately. So you introduce a lot of time. The second part is how do you maintain your air tightness and the performance over your building over the lifetime over the building. So there's kind of the more like a German method is kind of you actually have a separation layer. You run all your servers in the separation layer and the construction layer, which should be at least 35 mil to cover the depth of the PowerPoint, and you run everything in there. So now you separate layer by layer by layer, and you don't try to mix everything up. So in a normal resi build, everyone can afford having an additional layer on the insides. If you go more like for energy efficiency, you could have a 90 mil stud on the outside, then you 45 mil installation layer on the insides, and then you insulated layer on, and you get very, very close in some climates to passive house levels already. So just using this extra layer can actually improve your structure a lot and the performance.
A lot of concurrent benefits to breaking things up in this way, and I'm sure it would make the construction sequence more simple as well because you are really separating these responsibilities.
I wouldn't 100% agree to that one because like if you work with a smart vapor control layer, how do you run your Intello layer through internal walls when the walls are installed? So it means you actually have to think ahead of the game in this case, which is not a problem. I'm just saying is it just needs a slight change of thinking.
Fantastic. Well, that's just about all we have time for. Before we close, how can we get in touch with you, Daniel, if you have further questions?
Oh yeah, just visit us directly on the Proclima website. You can send emails to welcome@proclima.com.au. I'm pretty sure Luana's listening. She posted already the YouTube link for the video and she's posting the website. So you can just follow the link below and then you can contact us there.
Thank you so much. All right, I'll just do the pointing slides.
Just the last one, because I don't know what the overall what you're working in, but we also would have some more like commercial building sites and presentations about precast concretes, commercial wall buildups, like the status quo, how we could do it better on the best with pretty amazing product testings we did. So if there's interest, chat with Killen, and we have still heaps of presentations we could actually supply here on this platform too. Most likely would be Willy, not me. Then if Mark is still online, then he can roast Willy on these questions.
Fantastic. All right. Well, I'll do the closeout now. So the next installment in the Wood Solutions series will be on Tuesday, the 5th of August, and it will be on the Moonrabbin Mass Timber Warehouse and Showrooms by Robert Svars, who is a very experienced engineer with BizTech engineers who are definitely quiet achievers in this industry. So definitely get along to that one. And last but not least, the Australian Timber Design Awards are on again this year. A great chance to celebrate your favorite projects and designs in timber. The entries for this have been extended until the 11th of July. So if you know anyone who has a timber building that was completed recently that has not been entered in this or a previous year's award, please do get in touch and let them know that we're keen for another fantastic round of celebration in the best of Australian timber design this year. So thank you so much. Thank you, Dan, for joining us.
No worries, and thanks for the invite. See you soon.
Thank you. Ciao.
Ciao.